Solution, we said we want to solve this system of linear equation using Gaussian Elimination Method and Gauss-Jordan Elimination Method. First thing first, represent this system of linear equation using augmented form of matrix, and this is it, right? Having represent it like this, we've represented it. The next step is what? Identify your what? Pivot. By pivot, we mean the non-leading entry in a row, meaning there is a pivot in row 1, you have a pivot in row 1, pivot in row 2, and pivot in row 3, right? How do you identify the pivot in row 1? Generally, any number that comes first here becomes your first pivot in row 1. You know, we said by definition, pivot is identified basically after row reduction has been done, right? Row reduction must have been done before you identify your pivot. But in this case, given a question, we represented that question using augmented form of matrix. Your first pivot is this first number that you have here. What if I have 4 here? It means 4 becomes your first pivot. But in this case, I'm having 1. That is, 1 is your first pivot, right? Having identified your pivot, the next step is that the number under your pivot must be 0. Any possible way you can do your manipulation so as to make this number to be 0. That's what we'll be doing here. But observe something. I already have under this one, the numbers are what? -1 and 0, right? -1 and 0. Meaning from here, 0. This is already 0. Meaning I need to change this to 0. And even the question, I have 2x. I also have, meaning this place will be 2. What it means is that -1 will change to 0, 2 will change to 0. But luckily for us, we already have 0x here. Meaning there's no stress about row 3. My interest now is only what? Row 2. Are you getting my point? My interest is only what? Row 2. Then on row 2, what I'm focusing on is this -1. How do I make this -1 to be 0? Using 1, because this is my pivot. I'm using this one to change this -1 to 0. Now, how do you do our manipulation? What this means is that row 2 is changing. Row 2 is changing. Meaning my new row 2, what should be our manipulation? Row 1, negative row 1 plus row 2. Alright. Negative row 1 plus row 2. Meaning this column, this is row 1 for this column, right? So you are saying that, no, this can't work. -1 plus -1, this is -2 and not 0. This cannot work. Meaning that you have the manipulation that will work here. Another one, try another one. That will be what? Row 1 plus row 2. Row 1 plus row 2. Meaning for this column 1, what's your row 1? 1. Plus what's your row 2? -1. So you are saying that 1 minus 1 is what? 0. To make this -1 to be 0, this is the manipulation. Meaning, also take note that this guy is not really affecting this -1. It is affecting row 2 all through. Are you getting me? It is affecting row 2 all through. Alright, now from here, you already know that it is only row 2 that will change. Let's write our matrix, our augmented form of matrix, writing the one that won't change. Meaning, I'm writing row 1 and row 3.
How can I do the right manipulation to use?
Right, that's a good question. Now, I said that this thing that I are seeing here, from here, we are using row 1 plus row 2. I might say that I'm using, let's say my new row 2 should be 3 row 1 plus 3 row 2. Are you getting me? Now, let's solve. 3 row 1, meaning 3 all into bracket 1, right? Plus all into bracket 3 all into bracket -1. Meaning 3 minus 3, what do you have? 0. At the end, what do you get? 0. So what this means is that any possible way that you can manipulate and get 0, that's what you are doing. Any possible way you can manipulate and get 0, that's what you are doing. So for the easier one, you are making use of this guy. If you use this, you definitely get the same thing by the time you solve. But we are using the easier one, so which is row 1 plus row 2. Are you getting me? Now let's continue. So my augmented form of matrix the one that will not change, meaning that 1, -3, -4, 1, 0, 1, -4, and 5. Now let's solve for the row 2. Let's solve for row 2. Let's do it together. We said row 1 plus row 2, meaning that, let's bring it out. This is 1, -3, -4, and this is 1, right? Plus -1. Please call the numbers for me. Let's do it together. 1, -3, and 14. All right, let's solve. What do you have? 0 plus 2. This is what? -7, and this is what? 15. Meaning your new row 2 is what? 0, -2, -7, and what? 15. All right. We've identified our first pivot, and the numbers under my first pivot, I've changed it to 0. The next step is what? Identify your next pivot, right? My next pivot, where is it going to be? Row 1 or row 2 or row 3? Row 2. Why is it row 2? Because the pivot of row 1 first, then row 2, then row 3, right? Now check for your row 2. What's your pivot? -2. The question is why? Because it is the non-zero leading entry. It is the non-zero leading entry. Meaning you are making use of leading. The one that comes first. Leading. By leading, we mean the one that comes first. Right? Now, meaning from here, -2 becomes your pivot. And what's the task of your pivot? The number under your pivot must be 0. Are you getting me? Now, what will be the manipulation here? Any possible way to make this one to be 0? That's my interest now. Meaning row 3 will change. So how do you go about it? Using the same idea here. That will be what? -2 is our pivot, right? What will happen to the numbers under your pivot? 0. Meaning 1 is changing to 0. So how do you change this one to 0? If 1 is 0, we are saying that row 3 will change entirely. So what will be the manipulation that I'm going to write for row 3? So row 3 is equals to what? Row 2 minus 2 row 3. Okay, row 2 minus 2 row 3. Partially correct. It is row 2 plus row 3 plus 2 row 3. Row 2 plus 2 row 3. If you are telling me that row 2 minus 2 row 3, meaning -2 times 1, and that's -4. This is what I am saying. Row 2 minus what? 2 row 3. On row 2, what do you have? -2. -2 all into bracket. Row 3 is what? 1. -2, -2. This is what? -4. But if you use row 2 plus 2 row 3, meaning -2 plus all into bracket 2 times 1, and this is what? -2 plus 2, which is equal to 0. Are you getting me? That's it. Exactly. You are making use of the pivot. Any conclusion that you make with your pivot, it will affect the row entirely. It's your pivot you are making use of. In this case, this is my pivot. So the conclusion is the manipulation of row 3 is in between this -2 and 1, because -2 is your pivot here. So any manipulation that you are concluding for this one to be 0, that's what we will implement towards row 3. That's why it works. So we are saying that pivot is very important here. The ability of you identifying your pivot, that's what we need here. By the time we identify your pivot, the tax is all the number under your pivot becomes 0. So you are doing possible manipulation. My own manipulation might be different from your own. Just understand the concept that the numbers below your pivot must be 0. And pivot is identified after the junction has been done. Are you getting me? You know, from here now, let's say we've identified, this is the given question. My pivot here is what? 1. Agreed. For row 1. Abi? For row 2, my pivot is what? Can we identify pivot in row 2 for something like this? carry? No. So can you see where the definition comes in? Pivot is always identified after row reduction has been done. So that's why we're able to identify our pivot here, which is -2, and that's what you work with. Alright, let's write the manipulation for row 3, meaning that row 2 plus what? 2 row 3. Meaning row 3 will change all through. So let's write the one that won't change. Meaning that my new matrix, I have something like this. What do I have? Please let's do it together. 1, -3, -4, 1, 0, -2, -7, 15, 0. Okay, let's solve this. We have not solved this. Let's solve. Meaning that my row 3, I'm applying this guy. That would be what? 0, -2, -7, 15, plus 2 all into bracket 0, 1, -4, and 5. So open up. What do you have? 2 times this is what? 0. So we have 0, -2, -7, 15, plus this time this is what? 0, 2, negative what? 8, 10, 0, 0, -15, and 25. Meaning your new row 3, this is 0, 0, -15, and 25. Are you getting me? Now from here, what type of reduction is this? Gaussian elimination method. From what I explained earlier, the nature of Gaussian elimination method, this is it. So this is Gaussian elimination method. But from here, it can start solving the value of z, y, and x. Meaning this is x, this is x, this is y, and this is z. So from here, you can just say that -15z is equals to what? 25. Divide both sides by -15. What do you have? Z is equals to -5/3. Instead of you bringing it out like this, at the same time, you can make this pivot to be 1. Are you getting me? You can make this pivot to be 1. Make all your pivots to be 1. Just turn them to 1. Meaning that you are already starting the next reduction. Meaning Gauss-Jordan elimination method. From here, you are already done using Gaussian elimination method. But for Gauss-Jordan elimination method, having solved to this extent, up to this stage, what you should do for easier calculation, you continue with this, doesn't mean you will not get the same thing, but for easier calculation, make this 15 to be 1. Or better still, make all your entries diagonal to be 1. Are you getting me? You know, for Gauss-Jordan elimination method, directly, you know the value of x, you know the value of y, you know the value of z. So if these guys, they are 1, 1, it means x is equals to this, y is equals to this, and z is equals to this. Are you getting my point? If you make all of them to be 1, it will be easier for you to see at the end of the day by saying x is equals to what you have here, y is equals to this, and z is equals to this. So from here, whenever you solve Gaussian elimination method, you can bring out your workings like this. As it is like this is Gaussian elimination method. You can start bringing it out like this. You can start solving for x, y, z, right? But if you don't want to do that, you can just divide all through. You can stop here and you can go further. You going further, this same matrix, you can write it as 1, -3, -4, 1, 0, -2, -7, 0, 0, 1, 25/-15. This is 15. True or false? This matrix, we can still write it as this, right? What we did here is that we divide all through by -15. 25 divided by 15 is what? -5/3. Using this guy, let's solve for x, y, and z. With this matrix, z is equals to what? -5/3. I give you my answer. But using this one, what do you have? -15z is equals to 25. Divide all through by what? -15. Meaning that z is equals to what? Negative 5 over 3. Which one is easier? Which one is easier? You like this, Abi? What about this one? It's still the same thing. It's still the same thing. What we just did from here, we divided all through by negative 15. Meaning we are changing this diagonal to 1. 1, negative 3, negative 4, 1, 0, 1. This matrix, this is split, and this is split. So depending on, from here, you can solve, you can stop here. You get your answer for Gaussian elimination. You get your answer for x, y, z. You are still on the Gaussian elimination method, right? You get your answer. From here, using this one, you get your answer. Still on Gaussian elimination method, x, z, y, and z, you get your answer. Using this one, you still get x, y, and z. You are still under Gaussian elimination method. Are you getting me? What you just did is that you reduce your matrix. Meaning you are making diagonally, you are making it to be 1. It's not as if you continue with this one, you will not get it, you get it. But it's always easier if you make your diagonals to be 1. It's always easier. So what this means is that if you want to start your Gauss-Jordan elimination method, make your diagonal to be 1. Though not necessary, but make it to be 1. It will make your life easy. That's just it. It will be easier for you. We should make our diagonal to be 1. From here, I can start solving using Gauss-Jordan elimination method. I will definitely get the same thing. Are you getting me? I will definitely get the same thing. But if you are using this, you still get the same thing. It's just about you understanding it. But one thing I recommend for you is that let's make use of this. Let's make use of this. Do you know why? So that we avoid larger numbers. Are you getting me? Now, from here, for Gauss-Jordan elimination method, we are still going to solve for x, y, z here. That will be in the next video. But let me just explain this. For Gauss-Jordan elimination method, what it means is that this guy will change to 0. If we check what I gave you earlier, this one will change to 0, this one will change to 0, and this one too will change to 0. Abi? Now, you are reversing the case. When we started, we said this is our pivot. We make use of this one, which is our pivot. The numbers under it, we change it to 0. This negative 2 is our pivot, right? This negative 2, the number under it, we change it to 0. But this guy here now, the same way you did it, it's just like you did forward and backward. From this one, let's say from state 1 to state, let me say from state 1 to state 2. Are you getting me? From state 1 to state 2. That's Gaussian elimination method, right? From state 2 back to state 1 now, that was Gauss-Jordan elimination method. You are reversing the case. Now, up to this level now, in this case, your pivot will be what? Negative 15. That negative 15, the same way you did this guy, you will change this number to above negative 15 to be 0. Having done that, this guy becomes your next pivot. You make it to be 0. And from here, you now have that x is equal to this, y is equal to this, and z is equal to this. It's very simple. Are you getting me? But we will see that in the next video. That's for Gauss-Jordan elimination method. But let's solve this guy. So which matrix should we use to solve our x, y, z? This one, right? Okay, let's use this. Although you can try this by yourself, you can use this on your own, or you use this, you still get the same thing. But let's make it of this. Now from here, z is equals to what? Looking at this matrix, z is equals to minus 5 over 3. Y is equals to what?
You get 5 over 3.
Yeah, this is it. This is row 1, this is row 2, this is row 3. From row 3, z is equals to what? Negative 5 over 3. Because this is x, this is y, this is z. So z times 1 is z. Now, row 2, what do we have? Y plus what? When you see the matrix, it's all about you seeing and tell me what you are seeing. Y plus 7 over 2x, 7 over 2z is equals to what? Negative 15 over 2. Are you getting me? And we already know the value of z to be what? Negative 5 over 3. Let's substitute. Meaning that y plus 7 over 2 all into bracket minus 5 over 3 is equals to negative 15 over 2. Right? Now open up your bracket. Y is equals to negative 35 over 6. Y plus negative 35 over 6 is equals to negative 15 over 2. Let's do this together. That will be what? Y is equals to negative 15 over 2 plus 35 over 6. Hope no confusion. So XCM is what? 6, meaning Y is equals to 6. 6 divided by this is what? 3. 3 times this is what? Negative 45 plus 35. What do you have? Negative 10 over 6. 2 go here, 3. 2 go here, 5. Therefore, Y is equals to negative 5 over 3. Meaning, value of Y and Z, they are the same. Y is equals to Z, which is equals to negative 5 over 3. You know, we got Z and Y using this matrix. Let me say this is case 1. This is 2. And this is 3. We got the value of okay, let's solve for Z. Let's solve for X first. Let's solve for X. It's the same case 1. X is what? That will be what? X. That will be what? X negative 3y negative 4z is equals to 1. We already know the value of y and z. So let's substitute. Meaning x negative 3 open bracket
minus 4 negative 5 over 3 equals 1.
Alright, this cancel out, right? I have x plus 5 plus 20 over 3 is equals to 1. X is equals to 1 minus 5 minus 20 over 3, which is the same thing as over 1 over 1. What's the LCM? 3. 3 divided by this 3 times this is what? 3 minus 15 minus 20. So what do we have? This is what? Minus 12 minus 20. That's equals to minus 32 over 3. Therefore, x is equals to minus 32 over 3. Y is equals to z, which is equals to negative 5 over 3. Now, we got the value of x, y, z using what? Case 1, right? If you use case 2, the same value we got for x, y, z, we still get the same thing. Likewise for case 3. So what it means is that by the time you solve up to this extent, you can start solving the value of z, y, and x. You can proceed by writing your matrix in this format. Start solving x, y, z. Or you can have it in something of this nature. Start solving for x, y, z. Anyhow, if it is 1, if it is 2, if it is 3, you end up getting the same thing. It's all about understanding. Alright, from here, we've solved x, y, z using Gaussian Elimination Method, right? We only solved x, y, z using Gaussian Elimination Method. But for Gaussian Elimination Method, the difference is at the end, having done our reduction, we'll be seeing the value of x, we'll be seeing the value of y, and we'll be seeing the value of z. Meaning, looking at my matrix, I will know that x is equals to negative 5 over 3, y is equals to negative 5 over 3, and x is equals to negative 32 over 3, y is equals to negative 5 over 3, and z is equals to negative 5 over 3. That's what we want to do now.